please tell me to slow down. Si je parle trop vite, je vous en prie, demandez que je parle lentement. There is no point in my showing you everything I've got if all it does is whiz by too fast. So, slow me down if you need to. Okay, I'm no Russ. I am not Alan Knight. I started working with Glorp in about 2004, and I started doing weird Glorp stuff with Glorp about a year after that. And about a year ago, Alan gave me the Glorp OS project passwords, and Syncom put me in charge of Glorp in VisualWorks. And in the next 90 minutes, I want to show you some of what I know about Glorp, ideally cover all of my material, and even with luck, I will get far enough to expose brutally the limits of what I know and the fact that I am not Alan Knight. But I fear that we probably won't have that much luck and get that far, but we'll see something. As far as demos are concerned, to keep it accessible to you, the demo code is all, or most of it, is reusing Glorp tests. So if anyone is wanting to follow along with me, you can load Glorp on your machine, and basically you need Glorp, you need a database. Alternatively, this could be a talk. So it's up to you whether it's a tutorial or a talk for you. Anyone who wants can have Glorp tests loaded and just do on their own machine what I'm doing. Anyone who prefers can just watch, and most of the time I'll be doing the talking. So don't feel obliged to do that. If you do want to do that, then a thing you need to be aware of is the resource that you must set. Actually, I'm afraid I had to reset my screen size just before I started, so all my windows are going to open too big. But basically, you can see I've set a default login, and there are plenty on the class side to show you how to do this. So if anyone wants to do that, set it up, and so on. But otherwise, you'll just see what I'm doing. I will demo. So, Glorp is the brainchild of Alan Knight, longtime head of our engineering team, and now trying to make Dart benefit from Smalltalk's insights. Before he came to Syncom, Alan worked on TopLink, and that taught him a great deal about object relational mapping. And Glorp was therefore Alan getting TopLink right. As the saying goes, first make it run, next make it right, last make it fast. The fundamental point about Glorp is, in a strategic sense it's the next make it right version. And I think that gives it something that most object relational frameworks seriously do not have. Last make it fast, of course, is the next thing, and I will be talking about that too, but see also Tom Robinson's talk, last talk before the social event this afternoon. Glorp, you can read the acronym. It is very generic. It is great for Smalltalkers because it looks like Smalltalk. It does not have active record-like or other style restrictions, and the main thing about it is it remains flexible throughout the life cycle. With too many of these frameworks, you zip along at high speed in some greenfield situation, and then suddenly you get to the end of what's foreseen, and you're kind of in some totally undeveloped jungle, hacking your way, wondering what to do. The point about Glorp is it's more adapted to the real world, where you've got some legacy, some new stuff, and some requirements that are inconvenient, but they're there, and you're having to be flexible, not just at the start to get quick started, but right the way through the life cycle. And it's through the life cycle flexibility that I'll try to talk about. Obviously, it's the impedance mismatch problem, as they call it. Object-oriented world, relational world, not the same. And just trying to deal with that is what it's trying to do. And of course, it's SQL and it's also persistence. It doesn't just model, it also has to have an idea about commit, rollback, all that kind of stuff. Okay, so why did I have the effrontery to think that I can have anything worth saying? Well, let's look at some of the resources already. I'm here to tell you that Glorp is amazing. I'm not here to tell you that the documentation is quite so amazing. One of the first things that came out was Nevin Pratt's Glorp User Guide 0.3 PDF. We still have it in preview in our Syncom thing. It will always be in preview because I don't think Nevin's ever going to finish it now. I don't think my paraphrase on the slide there is unjust. It's kind of saying, GLORP's wonderful. Before getting into that, I'll show you kind of the basis of it, and I'll now, finish this later. And really, it's a great description of the very bottom end of GLORP. If you need to understand how GLORP is talking to the database, you know, it's really well worth reading, but I feel there's a great deal missed out. Then, of course, there's Roger Whitney's GLORP tutorial. And I mean, if anyone, you know, felt that they only had 90 minutes to devote on GLORP, I would have no quarrel with anyone who felt, well, I'm not going to spend it in Niall's talk, I'm going to go online and go through Roger's tutorial. And there's lots of good stuff in there. However, he's very frank, and for example, you will read this sentence, be locked key. I have no idea what this does. Okay, well, you know, Roger knows lots of things I don't, but I do know what be locked key does. And I greatly admire him for writing stuff like that. You know, the greatest wisdom is to admit what you don't know. So I'm sure I'll have opportunities before we get to the end of this talk to admit that too. Meanwhile, in SYNCOL, obviously, we've been trying to repair this stuff, and so there is the GLORP guide in VisualWorks, and that's a good getting started coverage. And it also, if you do wish to imitate Active Record, it has quite a good chapter on how you can imitate Active Record, but as I said, the value is the rest. And also in Object Studio, of course, the value proposition of Object Studio is enterprise domain modeling, and as a natural side effect of that, they then go on to being able to do excellent mapping. Felix was talking to me about how if you do a Magritte model, you've actually got some of the information you had in GLORP, and so maybe you could then take that to GLORP. I mean, Object Studio has that, so it's that's great, but obviously, mostly you don't have it, and always there will be times when you have to refine your code. So for the rest of this talk, we're kind of onto the rest. And basically, I decided to give this talk precisely to kick myself into developing that documentation further. Okay, so what are we actually going to do? Well, I'm going to try and talk you through the architecture of GLORP, give you a kind of context for where everything that I'm going to be talking about afterwards fits. I'm then going to try and walk through the process. So you've got your application, and you've got to try and somehow represent its persistence in GLORP. So there's an initial step of wanting to throw something down, and this gives me a brief opportunity for boasting about VisualWorks and Object Studio, especially Object Studio, because we have very cool tools for either taking legacy and turning them into a class model and initial mapping, or alternatively taking your model and shoving it out, yada yada. But sooner or later you revert to the by hand way. You're going to refine your mappings, and in any case, it's always, you know, it's first make it run, then make it right, last make it fast. You know, so there's always plenty to do there. Last of all, we'll go through all the query stuff. How do you read? How do you write? That's the very essence of it. And we'll look also at the transaction persistence. How do you commit? How do you roll back? And how does GLORP understand that? Now, the purpose of this talk is to make me try and set down the things that were less obvious, at least to me. You guys can all read, and you can also, therefore, any one of you, without any help from me, would be able to look at the code, look at Roger Whitney's tutorial, and get to the point where you could have one class in your image, one table in your code, and, you know, simple mappings between them, and then say, you know, session, read, something grows by class, write, whatever. So the point is that's...
I didn't get your... do you mean that GLORP is replacing active records? What is relationship between active records and GLORP?
Active record is just an example of a style that one could use to go from your domain model to a relational database. And so it's an example of one of the Ruby on Rails is an example of one of the things I was talking about. And if you use Active Record, you need to have, you know, you've got to have an id, you've got to have certain other things. Now, GLORP can do that, but the point is GLORP can do so much more. If someone brings you a legacy database that was written 20 years ago, it's not going to conform to Active Record style. So you want to be able to deal with that and add some of these stuff with it. And you'd like to do that as fast as if you were using Active Record.
Okay.
So that's, I was just using Active Record as an example of the kind of quick, fast on the rails, but limiting. So, I'm going to try and look at stuff that is probably very obvious to Alan, but wasn't so obvious to me. And of course, we're obviously going to cover a lot of basics in order to get to the point where we can look at any of this stuff. And finally, at the end of this talk, Tom and I, if there's any remaining time, Tom and I would love to have your examples of what's bad about GLORP. We're going to be sitting down with some specific customers, but we'd also love to sit down with anyone who has a GLORP, I can't see how to do this issue, or some concern, and we'd like to work with you, and that will improve our understanding as well as yours. Okay, so before we start, I'm guessing some people here know GLORP, a lot of it like the back of their hand, but there are some of you that perhaps thinking, what is this? So let's actually just take a minute to do something incredibly simple just to show you what's working. So we have a thing called the store workbook. Our configuration management system in Visualworks runs on GLORP. So I grab this and I just say, all right, let's open the store workbook on my thing. And now this is just a workspace which knows that it has a GLORP session. So if I go down to, for example, here, okay, here is your typical GLORP query. So basically, here am I saying, I want to read the stuff in the database that corresponds to my domain class store bundle. I want to have it returned to me ordered by timestamp, newest first, please. Then I want also to read the stuff corresponding to store bundle, where, make it the same store bundles as we were reading before, and I want to get I don't want to read all the rows, I just want to read the latest row, and kindly tell me which ones were written by Alan, and nobody has written anything since. So basically all this is saying is, I want to find store bundles that no one's updated since Alan last published a version of them. So you notice I've got a query inside a query, prepare my query, and then I say to session, execute my query, and if I run all that, then I get back, these are the 3 bundles that Alan had previously done. And if I step in here, I can see, okay, there it is, and I could walk through and see all sorts of data. And basically, data that was in various places in the database was just mapped to there and that stuff. So the point is, that's not intended to be, we'll look into detail later, but that was just to give anyone who's sort of thinking, what is this GLORP thing, an idea of what it actually does for you. Okay, the GLORP architecture. I had a lot of fun trying to draw this, and hopefully we'll be able to make sense of it. I better stand up and start pointing at this juncture. Okay, fundamentally you've got 2 things. You've got your relational database, and you've got your image. Inside your relational database, you have tables with their columns, their constraints, their indexes, and you also have transactions, the ability to handle the whole database thing. In your image, you already have some kind of external database interface. Your image, your Smalltalk image, knows how to talk to this database and probably knows how to talk to several databases. So that's already there. So along comes GLORP. At the top of your image, you have domain classes. You've got your ordinary Smalltalk classes that are powering your application. In between sits GLORP, and it's got various things to do. So first of all, it's obviously got to have some kind of adapter to the external interface layer, and that is a subclass of database accessor. So you'll notice there's a Visualworks database accessor, a Visual Age database accessor, various other kinds of accessors, and you could have 2 different kinds of accessors in one dialect because it had 2 different ways of accessing databases, and you needed one for each. So basically, you've got an adapter that says, I'll take GLORP's generics and know how to call into the database. Secondly, of course, you're trying to fool the database into living with your image and fool your image into living with the database. So relational databases have their own ideas of how you commit, you rollback, and so on. GLORP has to model that. So as well as all the stuff on the right, you've got a thing called unit of work, which, provided we get far enough, I'm going to get into how that relates to transaction and how GLORP has its image model of the status of the commit, rollback, continue cycle. Over here, our domain classes, obviously GLORP has to model the top and the bottom of this. Let me get on the other side so I'm not in your way. So at the bottom, it's got to have a model of your tables, your columns, your constraints, and your indexes. So you just have that, of course, database table object with its various other objects that relate to it. At the very top, and of course, that's not one for one. There is no requirement, obviously, that every table here be involved in your application, even if it's in the schema. There's no requirement that every column or every index be involved. Equally, there is no requirement that something you choose to model here is there. Maybe your legacy schema was a really rotten design. They should have had indexes here, here, and here, or more importantly, they should have had constraints here, here, and here, but they don't. You could actually write rubbish here, but you don't want to write rubbish, so you make sure that your GLORP understands that these are foreign keyed and these are constraints, even if the database is really stupid. Similarly, at the top, you're not going to persist everything. Your domain classes will have cache instars and computed instars that you're not going to write. So you need a model of which domain classes you're persisting and what parts of them you're persisting. And these parts are not too hard because they're one for one. There's no impedance mismatch. All this stuff in yellow is the impedance mismatch, and that's where GLORP tries to be really clever, where Alan has actually put his thinking cap on. You have these descriptor objects that map between class models and database fields, and they have mappings, and they're also joined, yada, yada, yada. We'll get into that. But anyway, that's the picture. Sorry.
Can you have views as well?
At the moment, you do not have a direct representation of a thing that's a view here and a thing that's a view up here. What we will discuss imaginary tables, and there's a sense in which an imaginary table and a view are very similar. But at the moment, Object Studio has done a little work for a customer to handle views in a certain way, and for the next cycle, one of our major tasks is views, proper one-one representation of views. But yes, at the moment, GLORP, you fake it, as it were, or you do certain things. So it's not there yet. I'm hoping that the very next release will, and that's not the release that's, correct me if I'm wrong, not quite out yet, but in a day or so. Yeah. But the very next release after that, I'm hoping that the answer will be say just yes, we have views. And as I said, we have a customer interest who we're kind of handling and we need to handle better. So anyway, that's the picture. If anyone needs me to go back to that picture at any point because they're thinking, where is he? Don't hesitate. Otherwise, I'll just assume that you have perfect eidetic recall and that you, having seen that, will have no doubt where I am or where I see Tom. Okay. Okay, so this is just the brief bit of boasting slide. You're getting started, so you're into the process, so let's start looking at it. So you're in greenfields or legacy. You've got to write the GLORP, generate the schema into the DB, or you've got to take your legacy and get that represented in GLORP. Obviously, if you were at past ESUGs and you heard Dirk's talk, you know all about the cool tools they have there. If you were at my last, real talk, my last long 10-minute talk, then Dirk was talking about the cool tools for generating, I was talking about the cool tools for reading legacy, yada, yada, yada. However, this is about actually understanding the nitty-gritty of GLORP, so we're not going to do anything of that. We're going to actually spend the rest of this talk doing stuff programmatically. And that's essential, of course, because however you get started, sooner or later you will be into the hard graft of crafting, refining the GLORP models, writing code in GLORP methods, and so on and so forth. However, I will mention, I've got to boast for just a little longer because not only does Object Studio have that, but Visualworks will be benefiting from that. For example, our ability to read store will, I hope, again, in the next cycle mean that we can verify that the customers have been good and have actually run all their update store things and they have all the indexes that give them the performance they need and so on. Tom and I will be working on that. Now, there's a standard way for actually persisting your GLORP model. You don't just need to persist data in the database, you actually need to persist your GLORP model in your image. And Alan likes standard way, which is not the only way you have to do it, but certainly that's how mostly we do it at the moment, is to have methods with class names embedded in methods. You take the descriptor system class, you subclass it, or you subclass one of the specialist abstract subclasses. So there's the Atlas descriptor system, there's the active record description system, there's the metadata descriptor system, depending on what domain you're in. But you basically subclass it, and then you give it a whole bunch of methods. Class model for da-da-da, table for da-da-da, descriptor for da-da-da. Obviously, in the old days, this kind of meant that refactoring was a bit of a pain. You want to rename your class, but all these methods still have your old name. So I honestly promise, this is the last time I will boast. I promise I will stop boasting after I've shown you this. Okay, so if I just take, we might as well go where we are here. In fact, if I say rename this class.
Could we change the fonts so that they are a bit larger?
Oh, right. Okay, let me cancel that and see if I can do that. Can anyone help me here? Do you mean a better screen display? Settings, okay, so you're, sorry, the VisualWorks settings, I think I'm already large here. Let me have a look, but I'm pretty sure I'm already as large as I'm allowed to be. Yeah, I'm already on large here. I think it's screen setting I'd have to up.
Okay, so don't.
No, seriously, if you can live with it, obviously I'd rather carry on, but if it's a problem, I will reset my screen settings if you like. Okay, right. Okay, so
maybe you can just press Command plus 1 or 2 times.
Command plus. Hang on a sec, I probably need to be in the Finder for that.
No, don't do it.
Plus.
Don't do it? Okay, don't do it.
Okay, right.
Steph says don't do it.
Okay, right. Okay, thanks. I appreciate it. Okay. There are seats up here. Come and be in my face. Okay, so basically, if I say rename that, so I'll call them Bill people, then okay, and now it recognizes, excuse me, your framework. And this is not just Glorp. This is a general utility where this is just Glorp using it. So if you have a framework which embeds bits of your domain in method names, then you can actually tell it, be aware that these methods mean something and you need to rename them. Obviously, I'm not going to rename anything, that would be great. So I'm just going to say no. But that would have handled the refactoring.
Forget about it.
Okay, end of boasting. No more boasting. Okay, so, simplest first. Your class models are pretty simple because all you're having to do, let's look at a class model before we actually go on. Okay, so that doesn't do it. Okay, so utterly trivial. As you can see, I need a model. I need to tell it what the various attributes are, which will be the inst vars. I need to give them names, and I need to give them types. Maybe I need to give them collections. I can take defaults. For example, that's going to be an ordered collection because I just said collection of, but I can say I want a collection bag of, I want a collection set of, etc., etc. Incredibly simple, trivial annotation of your existing class. So let's get back to the slide. Sorry, preferably without accidentally editing my image. That would be up. Okay, so if you don't want ordered collection, choose the appropriate collection class. You can simply trust that you never make a mistake and try and write stuff to the database. And if you try and send an integer where the database column says this should be a string, then of course it will swear at you. It might be better to actually have Glorp warn you that you're about to do that stupid thing, so set the types usually. The access is direct instvar output. You can make it perform getters and setters if you want to, but obviously because you're performing them, you're not faster there. A point to note is that the index is cached. If you've got a really complicated model, then bear in mind every time you set up a session, you're grabbing a new instance of your descriptor system. So that new instance is calling all these class 4, descriptor 4 methods and building up the model. That could actually get slow, so you might easily want to cache it. Just be aware, if you then shape change your classes, those indexes of the original positions are cached, so you probably want to flush your cache if you're actually developing. Probably, in fact, that would be a performance tweak. You develop and live with it, and then for performance, you cache your thing. It's one of those points. And you can, of course, make using getters and setters a default for your whole descriptor system if you need to. And again, in practice, it's of no. Okay, that was easy. Table models, not quite so trivial. You're
Maybe. So, you know, I don't understand anything. So maybe I'm just...
no, that's good.
So you know what I would like? I would like to understand. I have a book and I want to store it into a database. And I have a collection of books and I store them in a database. I don't understand what you're talking.
Okay, well if you had a book, you'd have to have a class model. I probably have an example here. So the first thing, I'm stepping you through, the first thing you do I actually have class model for book? I think probably is
Because
one.
I don't know, should we know GLORP before following the tutorial or not?
Well, I think,
Because maybe this is me, that is not in the right place. But
okay,
I just want to know.
I think we're getting there slowly. In a sense, as regards what I'm talking about at the moment, you have a book, so you've got a class,
Yes.
book, that class has some inst bars, so the very first thing you say is, okay, what parts of that am I going to persist? Maybe you don't want to persist the whole of the book, maybe you just do, so the very first thing you do will be to write a class model for GLORP book. And basically you're going to say, alright, which of the attributes, you know.
Okay.
So this is incredibly simple stuff, you know, literally you're getting started and you have to do it, and that's to do with the, sorry. A bit slow, come on. Going back. Sorry? Wow, going back is very slow. Okay, right. Okay, so basically all I'm just doing is turning that into something slightly more specific. So you're coding up this trivial part that you must do of doing your mapping. And that's pretty easy. Okay, so the table models, right. Okay, so
So wait, can you go back to the code there? This one, or any, the one with, there was a GLORP number, yeah. GLORP bank account number. So
because
that this is a pointer, this is what, this is a, because you have another table.
yes. So the point is, this is another mapped object, and all sorts of cleverness is going on underneath. I've called it title, so this is my domain. I was up at that top level, so I've just got domain classes, and of course those domain classes, you know that you've got relationships between them. So you know that the title is actually did I actually save that?
It seems like.
No, but I can abstract now. Now I understand.
But Steph, it's not the table that you're describing here.
It's the class.
It's just the relationship between the classes. It just says
No refactor.
this instance variable, I expect it to be a GLORP bank account number or a string. And just if you...
So this means that you are not talking about the mapping yet. You are just thinking abstractly. Okay, I have my domain. I want to have a kind of a view on this domain.
It's the highest level where you say, well, I have a class model for class X, and in this variable I expect the contents of class Y. And then when GLORP goes deeper, it needs some more meta information to understand what this GLORP bank account number class.
Your point is you can't do this. This is the clever bit, but you can't do this until you have trivial models of this and this. This is easy because it's OO to OO. There's no impedance mismatch. You know, I have domain classes. I have a model of those domain classes that I've communicated to GLORP. GLORP now knows what my domain classes are. It knows the particular bits I care about, and it has.
But go back to the, just go back to the browser. So this GLORP bank account number. This is for the exercise. This is a view on your
Yeah.
type.
I have a class called GLORP bank account. Let's let's get that out.
This is part of the domain. You see, is it the mapping?
Okay,
Try
so
to-
here is the class GLORP bank account. It's got an id, it's got an account number, it's got account holders, and it's got events received. Okay, so that's your domain class. You built a non-persistent in-image thing which had bank accounts and so on and so forth, and you need to persist it. So you've got your domain class, or you know what your domain class is going to be.
Okay.
So now you go to Glorp and you say, now Glorp, I'm going to tell you what your domain class is.
Because else I will miss everything. So.
Okay, right.
No,
okay, so here's
with
new
you.
attribute named
So-
id.
I get it now.
So I want to
And
understand
it.
now. So wait.
Yeah.
You write Glorp in the name of the class. Is it because this is an exercise?
No,
Or this
no,
is
it's because Alan Knight did it that way. Okay, so yeah,
I
let's
don't care of Alan Knight.
yeah, no, but the point is
Nay, stop to move. I cannot read that stuff because I don't understand what is written on the slide.
okay,
Keep the Smalltalk code that we
okay,
can
right, yeah, okay,
understand.
right, okay.
So,
So
I just
Alan-
want to understand.
the standard way,
Can you let the class definition please stop to move?
right?
So that I understand, smalltalk.glorp. This is a namespace. So why is it named like that? Should I? Is it, because I read, I read glorp test domain models. So this is. So normally, if I write my application, I will write Steph namespace.
Yep.
This is my book.
Yes.
Is it true or not? Is it true for that? For this class, the glorp
okay, sorry.
application?
You certainly don't need that. I'm not quite sure what you're asking me, but if you're asking me that you didn't have to call it that, and you could call it bank account or Steph bank account or any class,
Okay,
like,
the
that's
domain.
fine.
We are really
Yeah,
talking
Glorp
about
doesn't have to be there. Glorp is
Okay.
only there because Alan didn't want his bank account to clash with any other bank account.
I think he's asking if this is the real domain
Is
object.
it a real
Ah,
domain?
yeah. Right. Oh,
Okay,
right.
I just trying
Oh,
to
right,
understand the
right,
issue.
right. Okay, right, yeah. Okay, so
So,
I am
okay.
deliberately so that anyone who wanted could load the code in their image without redoing it. I am deliberately reusing basic test examples. These test examples have the word glorp stuck on the front of them. Not because it needs it, but simply because you want to load the tests and run them without having your glorp test bank account suddenly clash with the real bank account. So just to avoid that, the word glorp, and because it's in every dialect, not
Okay.
just the ones with namespace,
So-
the word glorp has been stuck on. This is a real domain object. It's an example, yes, it's
Okay.
my test, and therefore it's got the word glorp. It's a real domain object.
Is it necessary that these model classes are subclasses of? It is core point object. Okay.
So you see, so that's where
Yeah,
the
you see, it's a
domain-
subclass of object. It is not necessary, yes.
Okay.
This is a good flexible mapping framework. If it was active record, yes, they'd all be subclasses of a special class. But
Yeah.
this is glorp.
But this is being
Your domain could be written 10 years ago when you never heard of glorp. Now you come along and you plug it in. And one of the ways of plugging it in, not the only way you can do it, but one of the very common ways, which is very easy, and which I'm using, is to write a method with this name plugged in. So for that, just read my domain class. And for here, read my domain class. And yes, you see it here, account number here, account number here.
So, and that this is the description.
Yeah.
So the description, this is linked. What is the granularity of the description? You have one description for your complete system, or you
Yeah,
can.
you have one class. This is a single class, so let's just, I'm going to spawn this to make it clear. So there you are. I have this assists me in some of my testing and demonstrating. This is the actual example that we're looking at, and look at all the methods here. This is a complete, this one class, GLORP demo descriptor system, sorry, GLORP demo descriptor system. This one class has it's got some junk for test, but there you see there are a whole bunch of class models for various domains, and it's got all the stuff. There's no other class that is doing anything for GLORP. There are a huge number of classes that are actually in the domain. These are domain classes. GLORP, the bookstore customer, the book, the compressed money, the customer. These are all domain classes of these dummy domains in which we're demonstrating.
But normally, what is the pattern? This is that you have one system description per
One-
system.
Yes, one system perception is written, but you can have two. There is no reason why the same domain or the same database schema should not have two or three descriptor systems looking at it. A little later on, I'll be looking at an example
Okay.
of why you would do that. You might, for example, have the one that was how you understood the system 10 years ago, and you need to maintain that because there are some users who use it that way. But you now have the self-same schema being operated in a different way. So the constraints of data you're putting into it now are different, even though it's the same table.
Okay, and now the method that is in the back,
This one?
yes. So now this is the kind of a view from the system description of what you are interested, or the relationship that you have between where you describe your current object. So it means
Yes.
that if you have something that you don't even want to store, for example, you will not put it
Yes,
there.
exactly. You would have, there could be easily things there that you don't store and that you ignore. There are all sorts of, this is not an exact one for one, but it is easy because it's object-oriented to object-oriented. Okay, so, I repeat again, if I'm going too fast, tell me to go slowly. Si je parle trop vite, demandez que je parle lentement. Yeah, you know, that's what this is about, so that was good. Okay, let's get back to, okay, and we've noted, so you set up your attributes. If you set the types, Glorp will warn you that you're about to write an integer to a database table column that expects only strings.
And
If
that's
you-
what type is for?
That's what type is for, yeah.
Because I wondered if you don't add it,
Yeah, if you
it
don't
will
add
work
it,
anyways.
if you don't add it, basically you're saying, you know, my domain, I trust my domain model, I
Right,
know perfectly
right.
well this is intended to be an id. You notice, for example, we didn't set it on id in our example here.
Yeah.
This is fairly common, and this is just, you know, I'm really confident that my computing of ids is right. I'm really confident. I know, in fact, that I'm going to exploit the database for writing that, so I will never have a string where I'm expecting an id. I don't need to bother. But, you know, here, for the account number, I really do expect it to be an instance of that class that goes in, and I want Glorp to check the types. I don't want it to write something invalid to the database.
And how does it know actually what variable to map on for the bank account number? Because it needs to check the types on the
Yes, it
database.
does. It's
How-
doing all sorts of stuff in the background, and we will get there. So if I can park that for a bit, I'll tell you when I think you should know the answer to that. And
I have a question. So I understand. So the first part of the slide, I understand. You describe your model.
Yes.
Yeah, that's a relation. This is one attribute. I don't understand the direct access.
Okay, right. Okay, so having got that, you now have a situation in which you are going to say to the database, read. So you're going to say something like session read book. Okay? Or you're going to say session read book where author equals Stéphane Ducasse. And you want to get back, and in the database there are a bunch of rows, and they could be all over the place. It could be, you know, there could be a table for authors, there could be the rows only have the id 5, and 5 is mapped to Stéphane Ducasse, yada yada yada. So there's lots of joins and stuff going on. But eventually this comes back and gets marshaled into the class book that knows all about this stuff. At the top level, how does it actually get into that class? Glorp's got rows coming in, and at one point it's got to actually create a new instance of book, and it's got to say, right, the title is Pharaoh 3.0, the author is Stéphane Ducasse, and so on and so forth. So it's actually got to write to, it's got strings and it's got other stuff, it's got to write those into the right place. And it's creating subordinate objects, and it's got to put them in the right place. So the answer is, it normally uses instvar at or instvar at put. So when it's reading, when book is being read by the Glorp representation of book, it is actually using a direct instvar at or an instvar at put.
Okay, but so this means that from the user perspective, should I pay attention to that or not? Because I have the impression that from the
Yeah.
that your
Yeah.
slide should be cut in two. You have one that
Yes,
says,
yes.
oh, you
This is, the top part of the slide is if you're going to use Glorp,
Okay.
you're going to use it. The bottom part of the slide, so as I said, I'm going to try and mention some of the less obvious stuff, and I agree, it's all going to be mingled up.
Okay.
The bottom part of the slide is 99% of the time, who cares? It works. But suppose you have a really big descriptor system. You've got lots of complex stuff. You observe that your users are hitting you with sessions all the time. Every session instantiates a descriptor system. Every descriptor system takes time to call all this class model for this, class model for that, class model for the other, descriptor for this, descriptor for that. It's just building up this tree of information. So you say to yourself, I'm not going to do that all the time. You know, the database isn't changing. I'll do it once and cache it. Fine, you're fast. But then you shape change one of your classes. Book. I don't want one author. Stefan writes a book with a collaborator. You need authors, plural, or something like that. Right? So you shape change your class. You might have changed your insofar indices, and you've got them cached. So the top part is everyone has to worry about that. The bottom part, this bit, is all who cares, unless you get into this performance stuff, and you're starting to use special stuff. So sorry, I should have signposted that.
Okay.
And you can obviously write your own types. Let's go and look at one.
Neil, can you show us how to make it default for the whole descriptor system?
It's very obvious. You go to descriptor system and you can find the place where you just set it. Look for direct. The keywords is direct access. I mean, I won't do that because I'm slightly conscious of clock. But basically, go look for direct access in descriptor system, and you'll see a place where you can say, false. It's literally direct access : false. Okay, I think I'll skip. I think that was more useful than what I was going to show. I'll just say you can define types that are database oriented. There are a number of types already there. One is the version type, where you want a strategy for saying, look, if someone's already published version 1.0, and now you're about to publish version 1.0, do something about that. Don't allow it to happen. So there's a version field, and the point about that. Actually, sorry, I beg your pardon. I've gone on one. Sorry, my slides had got out of sync, so you weren't seeing the thing. Okay, so table models have a bit more to them. Okay, so the first place to look when you're doing this kind of stuff is the type. So first of all, let's look at a table model. Let's actually see this. Okay, so there's a table model. So, okay, you assign some fields. So again, this part is easy because you're now down at the bottom. We were up at the top before, we're down at the bottom. You're doing a mapping from a relational view to another relational view. It's an object-oriented model, but it's an object-oriented model of the relational system. So nothing very difficult here. Actually, there are tons of things that can get difficult, but the basics are very easy. So you can see what we're doing. You always use the platform because, of course, you want this to work when you connect to an SQL Server database, when you connect to Postgres, etc., etc. So you ask the platform, you set it up to be defined by the platform, you say what are primary keys. We'll get into lots more stuff later, but this is just fairly basic stuff. And having said that, there are things, for example, that will be made serial key obtained from the database by default, because I just said you're an integer, you're a primary key. If I had put serial here. Let's be careful not to say that. Okay. Right, so we've got things there, and my point is basically you need to look at database platform and subclasses. Oh, how do things come like this happen? I'm just doing up a class, you guys. What is the matter? Oh dear. What on earth has happened there? My image is suddenly locked up. If I go here and come back. Yeah. What on earth is going on there? something has somehow been triggered. I think I better save and reopen actually. That's the quickest way to just carry on without getting into a mess. This is at the moment when you suddenly think, I did remember to save my image, didn't I? Start over. Okay, so we were back to a very simple table model and just making the point, what's going on with table models. Okay, so,
Excuse me?
yes.
If you have a specific type for a database, for instance, Postgres as points or whatever, geographic data, can you add that, or is it?
Yes. That was literally just what I was getting to. Oh good, it does actually open up. So, the window the right size so my image is accustomed to the larger font size I had. Okay, so the point is, the methods that I'm looking at here is platform init4, platform varchar. They are methods that are defined in the types protocol, either here or in the subclasses. So the point is we have these various subclasses, they will override things, or they will even provide things that are only available, and then obviously it will work. I mean, you'll have a platform, Postgres type thing. If it's platform date time, and it's just picking up the particular implementation of Postgres, it all works, and then you go to SQL Server and it works. If it's platform Postgres unique in no other database date time format, then of course that will work fine when you connect to Postgres, and when you connect to the other it will see a DNU. I don't have this either. But I mean it's how you want to define it. But yes, you have specific stuff that is set up and done here, and that's how you get the various database types. And if there's one that you don't have, then you just add it. You can add to deal with a new database type and create a new platform here. Most of the inherited stuff should work. But you know what they say, SQL, it's a standard, so it's different everywhere. There are little things, and there are various places where these are the classes where you do the little things. Okay, so getting back to the slide. Actually, just let me get rid of it. Okay, so yes, you have all sorts of, sorry, I didn't mean to do that. You have all sorts of things. So, for example, the platform, it has obvious things like int4. It has various highly specific things like the in-memory sequence. You set up the thing to match whatever your schema has, and you also need to be aware of the database field configuring protocol. So, be primary key, pretty obvious. Be nullable, pretty obvious. Do you allow nil in Smalltalk is null in the database? That, of course, gets mapped. Do you allow non-unique values? Lock key. Okay, I loved that when Roger Whitney said, I have no idea what lock keys are. I thought, okay, there's one thing I know that Roger doesn't. Glorp will support an optimistic locking protocol. Set something to be a lock key, it's timestamped, for example, and you write it, someone else comes in, they've read it, they try to write, excuse me, the timestamp has changed, bang, you're out again. So that's optimistic logging with rollback. That's how you implement it. You just select some lock keys. And there are default values that you can assign. And there's more there, but basically database field, just as a database platform type protocol, database field configuring protocol, fine stuff. And of course you set the foreign keys. So let's actually find something that sets foreign keys and just look at it. I appreciate we're not yet, to the point of actually reading stuff, but hopefully we're getting there. Okay, so there's a lock key. You basically just have a version. Here's your book. You're updating the book, but if you've got co-authors, they're updating the book. You don't want both of them to write two versions of the book. So basically, Stefan is working on version 1.1 of his book. Meanwhile, Diego is working on version 1.2, but he read version 1.0. So he comes in and tries to write it, and it says, "Excuse me,